You know, the fun thing about piecewise functions is you open up a homework problem and you think you're just going to be graphing one thing, and surprise, there's 3 equations to graph. It's like a 3-for-1 deal. Isn't that great? So let's just get going with this. Remember what piecewise notation means. It means we have to graph each of these things separately. And I just want to start with the easiest one, right? Give us something to clear away right at the beginning. Let's start with this constant value right here. This says y equals -6. It's a flat line between the values of -1 and +2. So let's draw that. -6, huh? Okay, that's, let's see. It's going to look like this. -1 over 2, +2. Okay, there's my segment. And the way I do that line segment is with this button right here. You can see 2 clear endpoints on that. Now, once you draw the line, then you draw the endpoints. So I want to focus on these inequalities. X greater than or equal to -1. That means a closed dot at x equals -1 using the closed dot button. And this one right here, this x less than 2, that means it's an open dot right here, okay, using the open dot button. All right, so easy part's done. And if that's all you got, well, hey, you know, that's like 1/3 partial credit. So it's not nothing. Next part, let's do the top one. Let's just start right there. So this is an equation that says y equals -x minus 2 if x is less than or equal to -4. So what I'm going to do is take that -4 and plug it in. So y of -4 equals, that's not y times -4, it's y of -4, equals -4 minus 2. So y equals, what's that? That's 4 minus 2, which is 2. So y equals 2, x equals -4. Where are we here? Y equals 2, x equals -4. Yep, okay. There we are, right over there. And before I really commit to this as a dot or a circle or whatever, I want to finish drawing the line. And what you do now is you say, okay, I've got a point on the line. All I need to know is the slope. Okay, it's a slope of -1. And which direction does it go? Well, it goes to -infinity. So we're going to draw a line like this. Watch what's happening here. That is a slope of -1. See, it's 1 tick over, 1 tick up. And it's going out towards -infinity, off to the left. I knew it couldn't go this way because those are more positive values. That would be the wrong direction. So I'm going to do this arrow using a ray button on the graph. That you start at one point and then you click another point and that'll make an arrow pointing off in one direction. So now we need to put the end point on this ray, and because it's less than or equal to -4, that's going to be a closed dot right there. Okay. Now, last part. Got one more equation to fill in and then we're done with this. Well, then we can talk about the domain and range, which we haven't mentioned yet. So if x is greater than 2, y equals 2x minus 4. So y equals 2x minus 4. And if we're going to plug in x greater than 2. So I plug in x equals 2. I know it's supposed to be greater than, just bear with me. Y, where x equals 2, equals 2 times 2 minus 4. So that means y equals 4 minus 4, which is 0. So x is 2, y is 0. Right here. Now, I broke a rule by drawing that dot. I don't really mean for that dot to be permanent. I'm just using it as a placeholder because x has to be greater than that. So we're going to draw a ray going out from this guy. Okay, off in that direction. Oop, hold on. That's a slope 1. What's the slope here? It's 2. So it's going to be going up like this. That's clumsy, but you know, you get the idea. It's steep. It goes up 2 over 1, up 2 over 1. So that's my ray, and because x does not equal 2, I have to use an open dot right here. And I guess I can keep the same color scheme as before. We'll use an open dot right there, 2. Now, the graphing part is done. Okay, we've done everything the graph wanted, but there was one more question here. We wanted to talk about domain and range, and this is a very important part to talk about now. The domain is all the x values you can see, and I see an arrow going off to the left. Okay, so that's -infinity. And it comes along and hits -4. Stops at -4, not before -4, but on it, with that closed dot. And then, I'm going to move this over to give myself more space. And then, what happens next? Well, it picks up again at x equals -1. And then it goes until we get to, what is this? X equals 2. And that's an open parentheses because, you guessed it, that's an open dot. So we use a curvy parentheses. And then it picks up again at 2, right here. But if you notice, there are 2 open circles. So the function actually does not exist at the point x equals 2. It kind of hops from just to the left over 2 and gets just to the right. And then we go off to infinity on the other side. So that's your domain. Now the range is even screwier. We've got a function that if you look for the most negative y value you can find, right? It's -6. But it's just -6. It's not like -infinity to -6. So because it's the point -6, you say minimum -6, maximum -6, right? That looks really weird. But that's how you write it. And then you go union, and you find the next highest value of y, which is 0, with an open parentheses, or curvy parentheses, because it's an open circle dot. That means y does not actually exist at this point on x equals 2. But then from there, it goes up to infinity. And I want to point out something here. See this line right here? I kind of ignored this whole thing because the points y equal 2, y equal 3, y equal 4, those are already included on the line on the right, so I don't need to even think about the line on the left. All I care about is what the lowest value of y is and what the highest value of y is.